Hello everyone, welcome to another video lesson, and in this video lesson you will learn how to factor binomials and also four-term polynomials. So for any size of polynomial, it can have a GCF, so always check for a GCF first. Okay, so for example, number one, there is a GCF, and the GCF is, notice that this is 6, this is 12, and this is 14. The GCF when it comes to 6, 12, and 14 is 2. Okay, so that's part of the GCF. But also they have a to the first, a to the second, a to the third, so then we can factor out a for this one. Okay, for all of them actually. So 2a is the GCF. So once we know what the GCF is equal to, then let's factor it out. So then this is 2a, and this becomes 3a squared minus, this is 6a, and this is 7. Okay, so this is the answer to the first example. Right, the second example, this is something that you have not seen before, but you're seeing it today. So what you look for is what they have in common. So this is one expression or one term, and this is another term. And as you can see, what they have in common is the x plus 6. So I'm going to factor out the x plus 6, and then put together this x and this minus 8. Okay, in another parenthesis. So this is the answer to number 2. This will be very important for when you get introduced to factor by grouping. Okay, so next part is we're going to factor according to their size. So if we have a binomial, look for this to happen if it's a binomial. So this is a possibility, okay, and that is that it could be a difference of squares. So what does that mean? So when you see difference, there will be minus in between the two expressions. Okay, and squares means you take the square root. So if this is the case, then we can use the following formula. So the formula is a squared minus b squared is equal to a minus b times a plus b. So if you see difference of squares, then keep in mind that this formula can be used. So for example, we do have x squared and we have 100 on the first example. Okay, so I'm going to do it for this one, but then I'll just, I'm going to assume that you understand how to do this. If not, you can always ask me in class. Because we know that 100 is a perfect square. So for example, if I want to find, based on the formula, what a squared equals to, well, a squared is equal to x squared. That's in the place of a squared. Okay, and if I want to find what a is equal to, all I need to do is take the square root of x squared. So I'm going to say that a is equal to, so a is equal to the square root of x squared, which is x. Okay, and then what about b? Well, b in this case is 100, which means that b squared equals, b squared is 100. So if I want to find b, then all I need to do is take the square. Maybe I should do that here. Take the square of a squared and take the square of x squared, and that gives you this. What about b? Well, same thing. If you take the square root of b squared, that gives you b by itself. So then for now, b is equal to the square root of 100, which is 10. So then we have a and b in both cases. So then this is factored as x minus 10 times x plus 10. And that's the answer to this problem. Okay, number 2, if you take the square root of 16, that gives you 4. But notice this has a y square, which means a is equal to 4y minus b is the square root of 49, which is 7. So 4y minus 7, and the other is 4y plus 7. And again, if you don't follow this, just take the square root of 16y squared, that gives you 4y, and the square root of 49 gives you 7. So that's the answer to this one. This one here, what if you have to the 8th power, and this is to the 12th, and this is to the 16th? So notice again, if you take the square root of x to the 8th, that'll give you x to the 4th. What if you take the square root of y to the 12th and z to the 14? Well, this is minus y to the 12th will be y to the 6th. Z to the 14th will be z to the 7th power. So this is a and this is b. So then the other is x to the 4th plus y to the 6th times z to the 7th. And again, all you have to do is take the square root of x to the 8th, that gives you x to the 4th. Take the square root of y to the 12th, z to the 14th, that gives you y to the 6th and z to the 7th. Okay, again, I'll explain this further in the classroom. You're not getting it from the video. So example number 4, 25 is a perfect square. So if I take the square root of 25, that gives me 5, but this is x squared, so so this will be 5x. So then a is 5x, and square root of 1 is 1, so minus 1, and again 5x plus 1, okay, because a is 5x and b is 1, so I'm applying that formula. What about this one here? If you take the square root of 9x squared, that gives you that 9 is 3x. And if you take the square root of 64, that gives you 8. Square root of x is x, square root of x squared is x, square root of y to the 8th is y to the 4th. So this is a minus b. The other is a plus b, which is 3x plus 8x y to the 4th. Okay, and that's the answer to this one here. Next example, what if you have x to the 4th? So a, you take the square root of x to the 4th, that gives you x to the 2nd. So then a is x to the 2nd, and if you take the square root of 81, that gives you 9. And again, this will be a squared, a minus, plus 9. Okay, so this is, again, we're using the difference of squares. So I've given you 6 examples in this video about difference of squares. What about the next part? What if you have 4 terms? Okay, so this is where we're going to apply what we did here. So this we call factor by grouping. Okay, so grouping, which means you find the GCF first or twice. You find the GCF twice. So notice, I'm going to grab these. I'm going to group these 2 terms together. GCF of these 2 terms is x. Of these 2 terms is x. GCF of these 2 terms is 5. Okay, so then from this group, I'm going to factor out x, and then x squared divided by x is x, negative 2x divided by x is minus 2. And for this one, if I divide 5x by 5, that's a positive 5. And then this becomes x, and negative 10 divided by 5 is negative 2. And as you can see, we have a GCF of x minus 2 in the 2 groups, which means we can do what we did here. Okay, so I'm going to factor out x minus 2, and then put together x plus 5 in another parentheses. And this is the answer to that problem. Example number 2. For this one, GCF of 4x squared plus 7x is just the x, because 4 and 7 do not have any factors in common, given that 7 is prime. For this one, negative lead. Let's see, so for this one, we would say that 7 goes into 20 and 49. So then notice that that's a negative, so negative 7 is the GCF. So I'm going to factor out x from the first group, and then this becomes 4x and 4x plus 7. Okay, on the second group, I'm going to factor out a GCF of 7 minus or negative 7, and then this becomes 4x, and this becomes plus negative 49 divided by negative 7 is positive 7. As you can see, we have 4x plus 7 and 4x plus 7, so that's a GCF, which means I'm going to factor it out. So 4x plus 7, and then put together x minus 7. And this is that problem factored completely. Okay, one last example. For this one, GCF of, I'm going to group these 2 terms together. GCF is a squared. And GCF of this one is, they have b in common, so b squared. Okay, so then first group, I'm going to factor out a squared. So then this becomes a times b, and then plus instead of a squared, that becomes a 1. The other group, I'm factoring out b squared. So then this becomes, again, AB, because we have b to the 3rd and a to the 1st. So then for this one, b squared divided by b squared is 1. So as you can see, they have ab plus 1 and ab plus 1 in common, so that's a GCF. So I'm factoring out ab plus 1 and then putting together a squared plus b squared. So this is the answer to this problem. So again, if you're not getting this from the video, you can ask me questions in the classroom and I'll explain further about this. Okay, thank you for watching. See you soon. Bye-bye.